Hello, welcome to Math 1324. There we go. This is Chapter 10, Section 2, Example 4. And in this example, we want to match the correct graph of the function without using your calculator. Then, if you have a graphing calculator, use it to check your answers. Okay, so one thing we need to be aware of is that the graph that we're seeing here is not actually in standard form. So what we want to do is the following. The problem is that something inside that parentheses is wrong. Well, it's not wrong, it's just not in the standard form that we want in order to do this. Notice that we have 3 minus x. The number in front of x should always be just 1, period. Positive 1. Okay, so what number do we have there? We have an understood negative 1 in front of the x. So what are we going to do? We're going to factor that negative 1 out within that parentheses. So what I'm going to do is I'm going to write down negative 1 and then open a new parentheses. Now when we factor something out, remember that that's the same thing as unmultiplying, in other words, dividing every term within that parentheses by a negative 1. And so make sure we start with the x's first. Negative 1 divided by negative 1 is just a positive x. That's the reason we did this to begin with. We always want the number in front of x to be 1. And then 3 divided by negative 1 is negative 3. Good deal. Now, this right here is, in fact, the standard way of transforming. Now, it is standard form. It's just a little bit weird. Okay, so there we go. I'm going to go ahead and put a negative 1 right there just so we understand what's happening. Awesome. Knowing this, let's go ahead and look at the parent function. For this, the parent function is going to be y equals x squared because that's the exponent. In other words, to get the parent function, get rid of any multiplication or addition or subtraction, and you will get back the parent function. So this is multiplication, we get rid of this negative 1. This is multiplication, we get rid of the negative 1. Get rid of the subtraction, get rid of the subtraction. The only thing we would have left would be x to the second power. That's how you can see that. Now, if we were to graph that, it would look something like that. Now remember, there is a minimum value there. That's called the vertex, and it's going to be at the origin. Good. Now let's just work left to right. Let's work with this negative 1 there. Now that negative is what's important. The 1 means nothing, really, I'll be honest with you, because it's just multiplying the y values by 1. But what's important is that we have a negative there. That negative, what it does is it's a reflection. And if you go back to the first example, that's a reflection about the x-axis. In other words, we're reflecting across here. Now what's really happening is that we're going to multiply these y values by a negative 1 technically. So whatever the positive y value is, it's going to multiply, giving you a negative y value. So this, multiply the y by a negative 1, makes it go down there. This reflects down to there. That would reflect down to right there, 0, 0. And it just keeps going. And that's what it would look like. So if we were to graph y equals negative x squared, that is a reflection across the x-axis. And of course, that makes it look like this. Now, one thing to notice though is that the vertex is still in the same place because the y value is 0. 0 times anything is still 0. But it's a maximum now. So the vertex can be either a maximum or a minimum depending upon the depending upon whether there's a leading coefficient that is negative or positive. In this case, since there's a negative on the outside here, it's negative. So y equals negative x squared opens down like this. Y equals positive x squared opens up. So positive up, negative down. And that means that the vertex for the upwards is a minimum, but the vertex for the downward is a maximum. Good deal. Let's keep going. This -1. That -1 is on the inside, and it's negative there because it's multiplying. It's going to be another reflection. Now, because we've already talked about one reflection, the only other reflection that's left is across the y-axis. But the reason that's happening is because it's on the inside. It's the opposite, so we're going to do it to the x's, to the opposite, and we're going to divide everything by -1. But notice that if you divide by -1, if you have an x value here, it changes to the other side there. An x value here changes to the other side here, and so on and so forth. So believe it or not, y equals negative x squared is the exact same function. And it will look something like that, with the vertex being still at the origin. Good deal. Next, let's look at that +3 there. Sorry, -3 there. And that -3 it's inside the parentheses, so it's horizontal. So this is going to be a horizontal, and because it's plus or minus is always transformation, or excuse me, translation, which in this case I'm going to start calling a shift. And we do the opposite because it's to the x's. And since it says -3, we're going to add 3. In other words, we're going to go right 3 units. In other words, it's +3 to the x values. So that means that all of these are going to go right 3. And that will give me a new graph that looks something like this. Notice that the origin is now at 3, 0. Good deal. And we only have one other translation to do, and that is this -2. Now, that -2 is on the outside, but it is addition or subtraction, so that it is going to be vertical. So it's going to be a vertical shift, and it says -2, so we do what it says. And I really should highlight this. So it's going to go down 2 units. And of course we have this. So all of these are going to go down 2. Right there. And there's the vertex. So right 3, down 2. Awesome. And that would be the graph. Alrighty, well, I'll see you in the next video. Have fun.